Hey everybody, it's Eugene Liscio here. Welcome to Click3D. This is the program where we talk about photogrammetry and how you can use your digital camera to create really nice 3D models. Now, I've been seeing a lot of requests for creating a full 3D model, making a fully closed watertight mesh. And before I've shown, using a turntable like this, and I've got a little model here, and this is just a model of a little Korean woman here, traditional Korean woman, and I picked this up when I was on a working trip in Korea many years ago, and I'm going to photograph this and I'm going to include the bottom. Okay, so we're going to make a full model of this, including the bottom. So this is useful when, for example, you're creating things like game assets for video games, or if maybe it's an engineering component, or maybe you want to create a 3D animation of something, or you want to even create a 3D print. So this might be, just a case where you want everything completed and you don't want to have to sort of manually patch the bottom. You want all the colors and stuff. Now there isn't much going on here. This is pretty simple on the bottom, but let's just say we want this color. This looks like there's a little bit of glue from the label or something like that there. Okay, so let's go through this, and I'll go through the setup, and I am going to go through the camera settings. I'll talk about the turntable, the photographs, and then the processing as well. So we'll get started on that in just a second. Okay, so first thing is to consider the object or whatever it is that you're going to be photographing. So that's where I always start, because that's going to define how you're going to approach a photogrammetry project like this. And in this case, it's a small object. It's something that can easily fit on a turntable. It'll work well on a turntable because I can get it all centered and everything. And of course, I want to be able to capture the bottom. Now, some things that right off the bat, because it's a long object and it's not sort of wide, so it's tall, then I'm going to photograph with my camera rotated 90 degrees so I can sort of fill up the frame. And that's really important, filling up the frame. I'm also going to be using a turntable. So this particular turntable is one you can buy, online or whatever. I've posted links to this before, but what I've done is it comes black. So this is the black part here. It's got a little bit of shine because it's plastic, but I may even paint this black one day, just a flat matte black. That would be the best. You'll see the white side, it doesn't shine as much. So this was just a flat primer that I've used here, and it seems to be very helpful. The other thing is I just took this monitor and ripped a piece of paper off of a larger roll that I had, and I'm going to make this as the background. And the reason I want to do this is I'm going to be using masking to remove the base and the background. So anything that's white pretty much around the back of the object, I'm going to try and pull away automatically so I don't have to mess with it too much. So that'll automate the process. Now I could do everything, but the key with masking, especially when you're doing a full object, is to hide everything in the background or get rid of everything in the background so the photogrammetry software just sees the object. So if you had no frame of reference in the background on the turntable, it would just appear as if the camera was moving around this object and not the turntable. Okay, so it's just a white background. So if I took this, for example, and I pointed it up to just a blue sky and I couldn't see anything, right, and I just move it around this way or this way, you would have no idea what the orientation is because there's no frame of reference. And so removing this frame of reference on the model that we have makes it appear that the camera is moving around the object and not that the object is moving while the camera is still. So that's the secret. And that includes when we tilt it on its side like this. It appears like the camera just moved to the underside taking photos, and it has no frame of reference for the background. So that's the trick. In terms of lighting, I have just a LED light that's back here that's shining this way, and it's casting some shadows, you'll see here, away from the model. And I always cast the shadows away or in the same direction more or less that the camera is pointing. So all the shadows are going to be kind of back here, and the camera's not going to pick any of these up on the side. So that's useful. I also have a ring light over here, and I've actually covered it with paper just to diffuse the light a little bit more. And I could also do it to this light. I just tried it on that one. I found that it was causing some harsher shadows on this side, and I didn't want to catch them in the camera. So I'm going to try it like that and then see what happens. Now let's talk about camera settings. All right, so the camera that I'm using is a Nikon D7100. It's not a fancy camera, it's decent, it does the job. It's my main camera. I've been using it for a few years now. I love it, has all the features that I need. Maybe one day I'll upgrade, spend more money when I need to. But I'm using a 40mm macro lens. So I'm not, adjusting the zoom or anything like that. It's just one setting. I'm gonna focus and I'm gonna try and keep a single distance away from the model here. So I'm going to be using a remote, and I'm also going to be using manual settings. So I'm using an exposure of, well, I have to go back and check, but I'm using f/22 for my aperture, which is really high, so a very small opening. I'm gonna need an extended shutter speed, like maybe half a second, a second, or something like that. I still have to tweak it. Also, I've set my ISO down to 100, okay? Very low. I wanna get minimal noise on these images, and that will give me the best quality image. I'm just gonna shoot in JPEG. I'm not gonna bother converting from RAW to JPEG. That's fine for this particular thing. And I'm also gonna be photographing the entire model. Now, if I wanted really high resolution, I'd actually zoom in on the head and maybe the upper torso first and do a ring of photos there. And then I could go lower, do another ring of photos, and then kind of slowly capture everything, including the entire model. But for the purposes of this video, I'm just gonna fill the frame or the view with the entire model, take photos from a slightly high angle like this. Then I'm gonna take another round of photos going down a little bit low. I wanna catch the parts under the neck and some of these parts that I can't see from this particular direction. Once I've done that, what I'm gonna do is I'm gonna tilt this model maybe like this, and I'll take a photo like that, I'll rotate it like this, take another photo, and I'll start to get this part here with the bottom. And I will likely have to change the position of the camera here and maybe getting closer, maybe zoom in or whatever. But I'm gonna try and keep it equidistant more or less. So I may have to come up a little bit higher, start pointing down and do something like this. So I'm on manual settings. I'm gonna take some test shots and then we're gonna go from there and do my best to collect everything. So let me get started here. Okay, so I've moved things around a little bit, so I'm just gonna place this kind of back in the center. Just turn around here like that. I may try to maximize my view here a little bit. That is not too bad. I think the photos look pretty good. I'm gonna set up my remote here, make sure that I can fire that, and get over here, a bit lower. There we go, remote control mode. And I'm gonna go to the quick response mode. And let me just have a preview again. Now I'm gonna shut off the live view just because it runs faster without that. So, all right, I think I'm ready to go. Let's see what happens. Okay, so I've done one sort of round here, one circle all the way around. Now what I'm gonna do is I'm gonna drop the camera and point it slightly upwards so I get the underneath the chin and some of the other areas that I couldn't see here. So let's do that. Okay, so that does it for the middle or the underside a little bit. So that should have given me a bit better coverage. Now what I'm gonna do is I'm gonna tilt the model or put it on its side so that I can get the bottom, and I'll have to adjust the camera accordingly to get that. So let's do that right now. Okay, I think I've got it here. Sort of full frame. I'm getting part of the bottom. I may want to tilt this back. Actually, I want to get a little bit more of the bottom, and I don't really need to get the top side. Maybe like that. You know what? I'm going to go a little bit further back, just a hair. Okay, well, I think I've got enough photos to cap the bottom and get everything up top. So what we're gonna do is we're just gonna take the SD card, we're gonna go over to the computer, we're gonna process this, and we're gonna see what it looks like. Okay, so we are at the computer here, and what we're going to be doing is processing these images, and we're going to turn these into a 3D model. But the first thing we're going to do is have a look at some of the images and see the kinds of photographs that I had taken here. So you'll see that I've got the turntable. I'm going to move this around, and I got a bunch of different angles and such. Now, in full disclosure, I actually went back and I took a few more images. I was kind of close to the base, and I realized I should have taken a few more just to make sure. So you'll see some here. There's some extra photos of the base, and I just turned it to a few extra angles here so that I can process. Now, in terms of what we need to do here, what I'm going to be doing is processing these so that we first bring in the photos and then do masking. And so masking is a super useful method of eliminating the background. So like I was explaining before, what we're going to do is remove the background, so it kind of fakes out the photogrammetry package in thinking that what you're doing is actually moving the camera around the object. So I've gone in here, I've launched the masquerade, and what I'm going to be doing is showing you how you can do some really simple masking. And there are some different tools. There's polygon tools, selection tools, but if we just use the brush tools, you'll see at the bottom there's like a red brush and a blue brush, and what you can do is just click on the red brush, and anything that you paint red is what you're going to keep. And then the blue part, if I just hold the shift key, I can paint blue. And that basically is going to tell it what to remove. And what I can do is look at the mask, and you'll see that that is very clean. So this is one of the benefits of having a good background. So I've got, you know, a background with a slightly different color, and it's easy to remove. Kind of like a green screen, I guess, if you want to call it that. So I'll just try this again. I'll bring up another image. I'm going to just paint this here, paint blue on the background, and let it do the calculation. Okay, and you know, that doesn't look too bad. Okay, so what I'm going to do, I've got a mask that's already done. I'm just going to click on the automatic tool, so it's going to go ahead and calculate all the rest of them. I'm just going to go ahead and click yes. And once that is going here, I'm just going to let this go until it's completely done. And when it's done, I'll come back and I'll show you what it looks like. Okay, so it's gone through and it now did everything. And you'll look at some of the masks, they're not all perfect. And if you want, you can actually go in and tweak these. And this is usually what you have to do when you have a large series of images. They don't always mask perfectly. And especially if you don't have a good separation in the background. So, you know, if the color of the model is starting to blend into the background, then you're going to have an issue. So you can go in and just start brushing away some of the different little areas there for a better mask. And if I go to another one, you'll see, you know, this one didn't do all that well. So just I'm holding down the shift key, and then I'm going to brush this here. And once I let go, it's just going to calculate automatically. I need to color in a bunch of stuff here. And so you can see there's like little areas you can go in and you can tweak this until you're blue in the face. But of course, you know, if you have hundreds of images or even dozens of images and you got to really go in and tweak, this takes a lot of time. Okay. Now, sometimes you just have no choice. You have to use masking to your benefit, but just, you know, keep in mind that it is a time intensive exercise. And sometimes you're just stuck doing that and there's really no choice that you have. So let's move on. Okay, so we can see that we have all the masks loaded, which is great. We did them all, we processed them all. So what we need to do now is go to the next screen so that we can start the sparse reconstruction. And so that's where all the cameras are going to get matched, and where we're going to see the initial sort of point cloud and see how well all these things come together. So I'm just using, I'm going to use close range and deep on this one, and I'm just going to click run, and then in a minute I'm going to come back and we'll see what happens. Okay, so it looks like it's processed here, and we have a sparse point cloud in front of us with, there's some stray points there that you can see, which is often typical. You might see that on some models, but they tend to filter out. And I'm going to just shut off the camera positions because they're kind of getting annoying. And let's look around here. One thing I'm going to do is I'm going to realign this model because it's kind of sitting in a different orientation. So just going to quickly click on some points and get it so that it's pointed upwards. That's kind of what I want here. And you can see that I've got points on the bottom, which is what we wanted. And of course, I've got a pretty thorough set of sparse points from the front and the back and all the way around, which is really, really good. Now I'm also going to check the bounding box here. So what I got to do is just make sure that this box doesn't exclude any part of the model. So I want to make sure that it's aligned properly, and anything that's outside of the box, it will not process. So just did a quick fix on that. And what we're going to do now is the dense point cloud. So I'm just going to use the defaults, let it run, and as soon as we're done, I'll be back. Okay, we made it, and we now have a dense point cloud. And you can see we've got the bottom that's filled, which looks good, and around the model looks really good, front, back, and everything else. So what we're going to have to do next here is create a mesh. So from the points, you can see a lot of points. We're going to end up with a fairly dense mesh. And once we're done the mesh, we're going to have to do something else because there's going to be a lot of points. But let's just go ahead and go to mesh extraction. I'm going to use the defaults again. I'm going to click next, let this run, and when that's done, I will come back. So 3ds Zephyr is telling us that we were successful in creating a mesh, and if you look around here, you'll see that we do in fact have a fairly dense mesh at that. And even the default settings in many of the photogrammetry programs out there are going to give you a really, really dense mesh. If you actually go with high details and that sort of thing, you're going to get all kinds of stuff, you know, lots and lots of detail, which, you know, for game assets, that's really not what you're after. So if we take a look as we get close, you'll see that we've got like a lot of polygons here, and these little triangles and such, they cause the model to have a lot of weight. It's not what we want to export, so we want to optimize this somewhat. So what I'm going to be doing here is just having a look at how many polygons and triangles we have. So 1.2 and 2.4 million triangles, which is quite a lot. It may not seem like it, but you know, if this is just one little object in your game and everything has 2, 3, 4, 5, 10 million polygons, you're not going to be having much of a gaming experience. It's going to be more of a waiting experience. So we need to make sure we can get these down to a reasonable size. So there are some tools inside of many programs, many photogrammetry programs, that will help to reduce the size of the mesh. And so that's what we want to do. That's what we want to do now. And one of them has to do with just reducing the size of the number of polygons, which would be decimation. So if we go to Tools, Mesh Filter, and Decimation, that's one thing that you can do. The other one is retopology, but we're going to start with decimation, and then I'll talk about retopology a little bit later on. But really, decimation has to do with reducing the number of polygons and still having it look similar to the model that we have. And so here it says target vertices is about 600,000. I'm going to choose something much lower than that. So I'm going to choose something around 10,000, let's say. So a huge reduction. We were at 2.4 million, and I want to go down to about 10,000 polygons. And these other options here help maybe to give you a little bit more accuracy on the mesh sometimes. And I can apply the filter directly to this mesh, or I can clone and apply the filter. So I want to compare the two. So I'm going to keep the original, and I'm just going to clone and then apply the filter. So it's going to take just a couple minutes to process this, and then when it's done, I'm going to come right back and I shall show you the difference. All right, we've got a decimated mesh starting from the original, and you'll see that in the project navigator there it says, or in the project list it says mesh 1 filtered 1, and you can see right off the bat the polygons are severely reduced. Although if you just look at the model normally, it doesn't look too bad. So if we go to the original mesh, that's what it looks like. You can see a lot more of these triangles that are everywhere. And then when we go to the new one, and you'll notice that there's a lot less. So if we do a count, we had 2.4 million triangles on the original one, and if we go to the next one here, you can see that we have 10,000 points and about 20,000 triangles. So a huge reduction in the weight, let's call it, of this particular mesh. Now, one thing you'll notice when you look at this particular mesh, the geometry isn't too bad, but the colors look like they're off, or they look like it just doesn't look that great. And really what's happening is it's taking the vertices now and it's transferring the color of the points over to the mesh. And obviously we have less points, so it's going to look like lower resolution. So the way to fix something like that is just to go ahead and create a textured mesh, or excuse me, and the texture really is what I mean, and then apply the texture to the mesh. And that's a way of tricking your eye, and that's what they do in the gaming, for gaming assets. You create a very low polygon model, and then what you do is you apply a lot of materials on top of that, and those materials trick your eye into thinking that it's high resolution and super accurate, even though the geometry below is not that great. Now, retopology really has to do with reorganizing the triangles or the polygons that are on the mesh, and that's something that you can do. Now, it could mean different things in different programs. In 3ds Zephyr, it means that it's going to try and create an even triangle size throughout the model. So that's something that you can do. But in other programs, like in Blender or ZBrush, what'll happen is you can actually change the orientation and the number of polygons so that you can get a really low poly count. So what we're going to do here is do a textured mesh, or create the texture and then apply it to this low poly mesh. And what you're going to notice is that it's going to look really good. It's going to be very difficult to distinguish from the high resolution mesh that we had initially. So you can see here, there we go. All right, so what we're going to do is just go ahead, let's go to the workflow, create the textured mesh, and once that's done, I will come right back and we'll have a look. Okay, so our textured mesh is completed. And if you look around now, there's been a huge improvement in the quality of this particular mesh. If you remember before, it was all kind of like blurry or whatever. We had a very pixelated kind of color that was on the mesh, but now we have the high resolution texture that's on here, and we just took the regular one. I didn't even do a high quality texture on here. So even though we've retained the low triangle count or poly count, right? This is something that could, if it was in a game, it would trick your eye into thinking that it's better quality than the geometry that's underneath the texture. So this is a very typical workflow. There is a whole other part of this. If you didn't do this decimation or retopologizing inside of 3ds Zephyr, you would have to do this someplace else. A program like Blender, a program like ZBrush, 3ds Max, there's other programs that will allow you to do this. And it's really something that people specialize in the gaming industry, but this is a good start. And that's it for this one. So hopefully you found that interesting. I want to say thanks to everybody. Thanks for watching Click3D, and we'll see you on the next episode. Bye-bye.